So up until now, we've pretty much just been talking about one data type in R, vectors. And so now we're going to learn about other data types, data structures that you will likely come into contact with, and that will be helpful to know when thinking about data in R. So the first one that I want to discuss is called lists. And so lists are essentially a data type that is constructed of multiple vectors. And so it can have different data types, different data lengths, but essentially it's multiple vectors in one object. So for example, we can use the function list to bring together three values. And we can see in our console that it spits out these three subsets of values. And so before, when we use just the concatenate function, it spit out the values all in one row and under the same line. So this was just a single vector. Where now, when we use list, it gives us three separate vectors. And so when we go to save this, so say we want to just name it A, we can examine some of the key differences here. So if we look at class, it'll tell us that, yes, this is a list. When we look at the structure, it'll tell us the type of data. So the first vector in this list is numerical and it is the number 4, where the last one is character dog. Say we wanted to create a list with different lengths of vectors going into it. So we could include the number 4, include this vector called letters, which are just built in. It's a built-in list of values in R. And we can use dog as the third piece. And so again, we have this object saved as B, and it says it's a list of 3. And so let's look at the structure of B. So when we examine it, we can see we have a numerical vector here, and then we have a character vector with 26 different values, and then we have dog. So when we look at the length of this, it gives us the length of 3, which is basically saying there are 3 separate elements in this list. But if we wanted to look at specifically the length of, say, one of the interior vectors that make up this list, we can, using the square brackets, but using 2 square brackets to take an inside look at the list, specify the value that we want to look at. So say we want to look at the length of letters. We're going to put number 2 because that's the index value for letters. And it tells us that it's 26. So lists are important. I'm sure you'll come across them at some point, and especially working through some of the homeworks in this class. Data frames are one of the most common data types that you'll work with in R, and essentially they are like picky lists. And so you can have, different data variables in a data frame, but they all have to be the same length. So let's take a look at what we mean by this. So we have this vector letters. So we can see, it has these 26 values, and it kind of looks like what we're used to seeing with a vector. But if we want to turn this into a data frame, we can use the function data frame, letters. And now when we look at the console, it spits out quite a different shape of data. It essentially puts everything within letters into one column. So each value in the vector becomes a value in a row in one column. And so let's save this as a data frame. Data frame letters. So I've just called my data frame DF. And let's start to examine it. So if we look at length, it says 1. You might be wondering, what does that mean exactly? One way to understand this a little better is actually using the function dim for dimensions. And when we run this, we can see that there are 26 rows. So the first number is the number of rows, and then the second number is the column. And there's one column. So that's essentially what length was telling us. Number of columns. And another set of functions that's helpful here is nrow df, which isolates just the number of rows. Or you could use ncol, which also gives us the number of columns. Say we wanted to create a data frame with 2 columns. So let's just repeat the letter vector and see what happens here. So, oh, I got an error. It says unexpected comma in df2. And this is because I forgot to put the concatenate function to bind these together. Now we're good. df2. Let's look at what the structure of this looks like. Okay, so apologies here. Essentially, what has happened is the 2 vectors have been combined into one vector, but that's not what I was trying to do. I was trying to create a data frame. So I'm going to delete the C function and put data frame here. And now it'll show us what I was hoping. So essentially now we have 2 columns. We have letters, and then R has repeated letters again, but added a number to help differentiate that this column was different. And so that's something that's native to R, that will happen if you have any sort of repeated names in your columns. And then if we look at the dimensions, we can see that now we have 26 rows of data and 2 columns. So one other thing I wanted to mention is on that topic of recycling that we've been bringing up throughout the class. So say we want to create a data frame of letters, and then I also want a column called, or I don't know, I'll create a column with the word dog in it. So we can see when I do this, it just repeats dog all the way down. What about if I put a number there? You can see again, it just creates a new column and adds 1. What if we did 1 through 2? When we examine this in the console, we can see that R has decided to recycle 1 and 2, the exact amount that there are rows in the data frame, because in a data frame, the lengths have to be the same. So what if we did letters and then 1 through 3? So when we did this before in looking at vector math, we just got a warning that basically said, you have different lengths of vectors here. I'm still going to do it, but just so you know. And then in this case, when we're creating a data frame, it is not happy. It gives us an error. And it says that basically this is implying differing numbers of rows. So it can't easily determine how it wants us to include 1 through 3. So that's all I'll say for data frames right now. We're going to be working with them a ton, so you'll get familiar with sort of the ins and outs of them. One other type of data I wanted to bring up are matrices. So matrices are basically a data frame, but it has to be the same exact type of data in the X and the Y. And so essentially they're two-dimensional. They'll have two variables, and they have to be either all numerical or all character, um, just the same type of data. And so they're not super common to work with. I end up working with them quite a bit because of network data. But they're just good to know a little bit about. So just a quick example of what a matrix could look like. So I'm going to specify the number of rows, oops, and the number of columns. So this is a symmetrical matrix. And so I basically just said there's 10 rows, 10 columns, but I didn't feed it any information. So if I wanted to actually fill this in with values, I could specify a range of values or series of values, and then the size of it. And it will now fill in that information. And something you might notice is that it's counting 1 to 10 in each of the columns and not across. So each row is actually the same value. So this is a default in the matrix function. And so if you wanted to change how that was working, you could use this function, this argument called by row equals true. And now it will do the sequence of values across each row. So one other thing with this is you might want to, get out certain information, subset information out of the matrix. So I'm going to save my matrix as an object and show you all what I mean. So in the console, we can see like this is the matrix that was spit out earlier. And instead of column names or row names, R is telling us how it sees the indexing of this value. So it's basically saying this first value 1 is in row 1, which is denoted by the number on the left side of the comma, in column 1. So the numbers on the right side of the comma say the exact column. So if I wanted to extract the third value in the first row, I would first write the row number, which is 1, and then the column number, 3, and it should give me a 3. And then if I wanted to extract multiple values, I could do that by using that concatenate function. I forgot to put an M in front. Let's say we do 5, 6, then it'll give us multiple values. So another type of data, and this is well, actually, no, there's 2 more types. So the next one I wanted to talk about were arrays, and I'm not going to go into any examples of arrays, but just more of a like, hey, these exist. And arrays are essentially matrices, but in 3 dimensions. So they have an X, Y, and a Z value. And they are essentially stacked matrices. So the way that I've come across them, I'll just write out the name of it so you don't forget. But the way I've come across this is if I have like multiple networks that are related to one another, and I might want to look at all of those in relation to each other. So Z gives some sort of height value to the array. So the last data type I want to talk through are factors. And essentially, factors are like fancy characters. They are characters, but with some sort of like level value or order to them. And so I'm bringing this up because factors end up being really handy and convenient to use at times, um, especially when you want to specify a certain order in your characters that is different than what R gives. So I'm going to go through some examples just to show you all what I'm talking about, but let's first start with creating a response vector. So we're going to use the function factor to make it into a factor. Then we use the C function, which we've been using a lot so far. And I'm going to type in a bunch of values here for, let's just pretend this was like a survey question about whether someone would eat at a restaurant again or something. So we have all these values and we save it as an object. And let's check it out. So let's look at the class. And, before when we made a vector, it gave us a different class, but now that we have called this a factor, it tells us that this is in fact a factor. Okay. So another helpful function is levels. And this is because R has assigned levels to the different responses, the different words in the response object. And so we see, okay, it says levels. These are the three different names, but it's not really clear like which level is what. So we're going to get to that. But another function that you can use is n levels to understand the number of unique levels in the factor. And then we can use type of to understand a little more about what R is thinking of when it sees this object here. So we know it's a factor, but then when we type of, it actually tells us it's an integer, which is a little confusing because at surface value, each of these words looks like a character. And this is because R doesn't see them as the name that we've given it. It sees it actually as a number and a level. And so essentially, how we can understand how R is seeing it is if we look at response, it says levels, maybe, no, yes. And essentially the first level, so integer that's equal to 1 or index value equal to 1 is maybe. The second level is no, and the third level is yes. And the order of these is based on alphabetical order. So R just automatically assigns order based on the alphabet, or if it's numerical, I think that's an interesting thing that we can examine later, but I think it would also do it by size. So as it gets bigger, the levels go up. But there might be cases where we want to change this order. Like maybe no, yes doesn't seem like that intuitive to me. I think that actually I would want the response to be a little different. So we can use this factor function again, and we can actually specify the levels. So levels, oops, I meant to put the equal sign on the other side of levels. And let's say yes is the first level, maybe is the second level, and no is the third level. And then when we type in response, we now get the levels in that same exact order. And this is helpful if, say, you are doing a plot, ggplot, and you want to, map or plot these specific categories, but you want them to be in this order of yes, maybe, no. You can use factor to help order them. So what about if we want to convert the factor? So if we want to convert to as character instead of factor, we can use this function called as character. And great, R was able to successfully convert this. But you are going to run into an issue if you ever were to work with numbers. So say we have years factored, oops, and we have a bunch of numbers. So we run this, and then let's just look at the factor on its own. Okay, so it has these levels. And this is what I was talking about earlier, how R will just automatically factor by increasing order. And so 1977 is the lowest number and the first level. But say we wanted to convert those to numeric. So we run this, and we can see that R has actually given a series of values that do not align with the actual year. And this is because R is returning literally the level, so the integer that it's given to each level. So remember when I said 1977 was level 1? Well, since that's the third value in the factor, that's where 1 is. So one workaround to do that, to work with factor data like this, is actually using as character first to convert, and then as numeric, and it will retain those original number values. Okay, we are almost done. Just one more piece, and that is renaming the different levels. This, might come up again when you're visualizing data and you want it to specify a certain name instead of what you've been using in your data frame. So we can examine the levels again with this function levels. And then we can look at specific values by indexing. So actually, I'll just start with levels, response is our factor, and then say, let's get the first level here. Oops, I forgot to close a parenthesis. We want levels of response and then index the first value. Okay. So essentially that is the lowercase yes, but what if we wanted to rename it uppercase yes? Then when we look at our factor, we can see that it's renamed that level. And it's possible to actually change the name of all three if you wanted. So we can go levels, response, oops. And actually we don't need to save this as an object. We can just do levels, response, and that's how we're saving it. So we're actually changing this factor, and we can just write out the new names that we want. Maybe, and then no. Then they should all be updated. Great. So that's it for this part of the lectures. Thank you so much for watching, and we'll go over some of this again in class this week.